I'm going to make this a short one. Try to anyway. Here we have the machine restored back to the second condition that we wish to operate, which is a more balanced state. We have 0.23, 0.24, and 0.25 stator delivery lines. We have energized the field. This is the state with no loads. Now once again, we're going to put the load on there, the coil that we're going to use to demonstrate the wireless Tesla coil. We're going to hook that coil up. That is the unloaded state. Something seems to have gone wrong. What went wrong? You looking for the right coil? Yes, we did. Now after this crap in this video. Oh, we got a shorted arc now. I see that. Then we need to get in there, correct that short. Where's my stick at? As indicated before, okay, here's our conditions now when something went wrong. The arc bars are touching right now. And because the arc bars are touching, we're only procuring 2.1 milliamps, and of course we got a voltage meter across the arc gap, but since the arc gap is shorted, it's not going to read anything. We need to open that arc gap. Okay, we've opened the arc gap to a small gap. We see that even without a field, we have 111 volts across the arc gap. Now, what we're going to do here is, on the previous demonstration, we couldn't figure out what was all going wrong. This particular meter here suffered some kind of back EMF or some kind of transient which completely disabled its operation. That meant that's $40 for another meter. Well, this is an old one. But we found out we don't want to do that again. This is the most critical, one of the more critical components of it. And then we want to disconnect. We can't forget things now. Once we turn this device on to demonstrate the wireless Tesla coil, we still got the voltage meter across the arc gap. We want to make sure that thing ain't on there. Any way or form. That's been removed from the picture. Now, since we damaged the meter, well, we had big problems getting that thing to work again. We're also going to disable that meter. We're going to put a short across it, and it's going to read 0, and hopefully any damaging effects won't hit the meter. Now we've shorted that out. We see that for some reason, even though we've shorted it out, there's still current going through the meter. We're going to take one step further and just disconnect the lead from the meter entirely. What we're going to do now is we understand that everything's still working. Well, I hope it's still working. It should still be working. We're going to go out here, back up. We're going to turn the device on, and when we up to our operating voltage, make sure we got a functioning arc gap. And then what I'm going to go and do is I'm going to lift that top coil up off the coil that's underneath of it, and that will disable the Tesla coil from functioning. Going in there to turn the field on. We don't have an arc gap yet. We now have a functioning machine. Here's our arc gap. Corrosion develops on this form of metal, and we found out that the arc gap won't necessarily last very long. There's already corrosion on it. That's why its operation is appearing sporadic. Now we're going to go over here. And now we're going to lift that coil up and watch the results. Looks like we can see the neon lighting. Up. This is a wireless Tesla coil. All the energy from the primary comes through the air. Look at that. We only, it's better than a simple distance feature than a plug, eh? Might be overcoupled in some respects. That real complete demonstration of the wireless Tesla coil. Thank you.